Hey everyone, hope you're doing well. In this video, we're going to be going over how to graph quadratics in intercept form. Okay, so in order to warm up, all right, we need to go over some characteristics of quadratics. So we're going to talk about the vertex and the x-intercepts. All right, the vertex is very important, and the x-intercepts are particularly important with this form. So if we circle and label, so we got the vertex is going to be up there. So that's going to be at -3, 4. All right. We have two x-intercepts. The x-intercepts are where it crosses the x-axis. So that's at -5, 0, and at -1, 0. And you're going to do this 4 times. And so I encourage you guys to do the other 3, B, C, and D on your own, and then see what do you notice about the vertex and x-intercepts, all right? So you can go ahead and do that now. I'm just going to tell you now, hopefully, maybe you found out. If you look at all of these cases, so we've got 0, 0, 4, 0, and then a vertex at 2, -4. If you look at all these, all right, you should notice that the vertex is in the middle of the 2 x-intercepts. So, and that should be expected because we know the vertex is where the axis of symmetry is, right? And we know everything is symmetric on both sides of the axis of symmetry. It's mirrored. So the x-intercepts are the same distance apart from the axis of symmetry. So therefore, the axis of symmetry and the vertex should be splitting the x-intercepts right down the middle, all right? And that's helpful for us because we can use intercept form to very easily get the x-intercepts, all right? When you solve by factoring, all right, if we set this equal to 0 and we split this up into 2 equations, what you are finding is the x-intercepts, right? You're factoring when y is 0. When y is 0, that is where the x-intercepts are. So this graph has x-intercepts at 0 and 4. So therefore, that matches with graph C. And we can do that for all of them. So this one, set it equal to 0. We've got x minus 2 equals 0 and x minus 4 equals 0. So that'll be x equals 2 and x equals 4. So which graph has x-intercepts at 2 and 4? Well, it looks like right there, right? So B, we would get B for that one. For this one, again, set it equal to 0. The negative sign, anything out in front does not affect the vertexes. So we don't have to do anything with that, or sorry, the x-intercepts, because -1 can never equal 0. So we got x equals -5, and we've got x equals -1. So this would be the first one that we did, right? A. Again, the 2 doesn't affect anything, all right? X equals -3. So that will be graph D. Okay. So this is how you can kind of see maybe how we're going to graph this in intercept form. So the A value out in front, remember, what do A values do? It's the same thing that A values have been doing this whole course and will continue to do this whole course. Oh, thank you.
Sorry, I don't know. Did just tell it on the ground out there.
Thank you. Ooh, someone brought me my ID that I lost. That's good. Anyway, okay. So the A-intercept, it does the same thing. It stretches and compresses the graph, but what we're interested actually in is whether the graph is going to be going up or down. All right, that can be told from the A value. And the P and Q, right, remember, those are our x-intercepts. All right, so when you're actually factor it and then solve. So we're going to graph these two, all right? I'll show you how to graph the first one, and then you guys can try the second one. So what we're going to do here is first we're going to get the zeros or x-intercepts. So we've got to set this equal to 0. Then we want to set both parentheses equal to 0. All right, so we add the 5 over, we get x equals 5. Add the 3 over, we get x equals 3. All right, so our x-intercepts are at 5, 0, and 3, 0. All right. Now, how do we find the axis of symmetry? So I would actually go down and graph the x-intercepts as soon as you know them. So we've got one right there at 5, one right there at 3, and then there's many different ways that you could go about this. Basically, you're trying to figure out what's the number in between those two. Well, the number halfway in between them is clearly 4, right? So you can tell that by looking at the graph. So our x-intercept, our axis of symmetry is going to be x equals 4. Now, that's just kind of by looking at the graph and being able to tell. If you want a math way with the numbers, all right, the axis of symmetry is always the mean of your two numbers, all right, whatever your x-intercepts are. So if you remember, the mean is add them together, divide by 2. So if we do that, we get 8 divided by 2, which is 4. So this is a way that always works. It's just in case you wanted it. The vertex, how do we get the vertex? Well, think about it. We know the axis of symmetry is 4. How do we find the second coordinate of our vertex? Hopefully you guys know this by now, but if you have an x value, you can plug it in. So we're going to plug in 4 into our equation. So we've got 4 minus 5 and times 4 minus 3, okay? So you can plug it in like that, and whatever this equals to, that'll be your vertex. So it's just like in standard form when we got the axis of symmetry and we plugged it back in. And so, by the way, this is a multiplication problem, so remember that. So we got 4 minus 5, that's -1. 4 minus 3, that's 1. So -1 times 1 is -1. So our vertex is at 4, -1. Now, is the vertex a maximum or minimum? So again, there's two ways to tell, all right? The first way to tell is looking at your A value, all right? Our A value is 1, right? We don't have an A value, but it's 1. Well, we don't have an A in the equation. We still have an A value, but it's positive. So positive means going up, all right? So this is the exact same thing as in standard form, all right? It's going up, so therefore the vertex is going to be a minimum. However, you could also tell that by looking at the graph, right? If the vertex is below, then you know your U has to be like that, so it's a minimum. Now, how do we finish this, all right? Because we've only got 3 points, remember. We usually want 5 points. So what we're going to do is we are going to use Desmos, all right? Some of you guys are really fighting Desmos. And I don't know why, because it's a graphing calculator. If you have your own graphing calculator, you can use that, but most of you don't. So if we put our graph into Desmos, all right, it gives us our parabola. We can turn it into a table, all right? And so we want to get 2 more points on our graph. Now, hold on. Our vertex is 4, -1. So we want to really get the points that are surrounding the vertex. all right? So think about if you want 5 points, right? We already have the zeros and we already have the vertex. So the other 2 points we want, I can't really draw on this. The other 2 points we want are those 2 points, right? So we've got 2, 3 and 6, 3. Those are the ones that are gonna best fit on our graph. So 2, 3 and 6, 3. So there's our 5 points. And now we can draw our U. And that's graphed. All right? So that's how you do this. So I encourage you guys right now to pause this video again. Try the second one on your own. All right? And then I will tell you the answer after you've done that. Okay, so hopefully you tried the second one. Hopefully you thought it was easy. So real quick, let's go through this. All right, for the x-intercepts, you should have got -5 and -1. For the axis of symmetry, you should have got x equals -3. All right, if we plug that back in, I don't want to do this in my head and mess up. Remember, you got that negative sign out in front. This is 2, that's -2. So 2 times -2 is -4, but there's another negative, so we've got -3, 4. So for the vertex, you should have got -3, 4. And again, there's a negative out in front, which means our graph is going down, which means it's going to be a maximum. So if we plot our points, we've got -3, 4. Our x-intercepts were at -5 and -1. And so if you wanted other points, so this one, you could have done it 2 ways, all right? There's actually 2 points here in between, so you could have got those 2 points right there from Desmos, and this would be your 5 points. I would always say try and get the closest point to the vertexes that you don't already have, all right? But if you went to the outside, I believe the other points would be at -5 and -7. So if you got those points, that's what it would look like. So this would be your U. But you don't have to get 7. You only had to get one of those 2 sets of points. So hopefully you got that correct. Hopefully this all makes sense for you. If you have any questions, let me know and have a great day.